Hi, this is Mrs. Kidman, and in this video, we are going to look at how conditional probabilities affect what we're looking at. So in this problem here, it says a quality control inspector checks for defective parts. The table shows the results of the inspector's work. What we need to find is A, we want to find the probability that a defective part actually passes or it works. And then we also want to find the probability that a non-defective part fails. Now, what happens here is in this terminology that we have limited our scope. So typically, probability is out of the whole thing. But what we're looking at here is the probability of getting a defective part that passes is actually a conditional probability, because what happens is we're only looking at defective parts. So in part A here, where it says we want a defective part that passes, that defective means I'm going to limit my search to only this portion here. So really what we're looking at is I want to find what's the probability that something passes given that it's defective. Okay, that's really what this question is asking us, but using that terminology or that language, that sentence of finding out if something passes given that it's defective is not fluid in the English language. So rather we would say a defective part passes. But really what this means is I'm looking for something like this. Now a conditional probability limits what I'm looking at. So instead of saying I want everything that passes, I want just in the defective parts to see what passes. So instead of it being all of it, I'm going to now look at the probability that it passes, which is a 3, out of just the defective parts. And just the defective parts is actually going to be 39. So the probability that a defective part passes is the same thing as the probability that something passes given it's defective. So given it's defective means I'm only going to look at those 39 defective parts to determine what passes in that situation. And in this case, 3 pieces pass. Now for part B, it's going to be the same thing. So instead of the probability that non-defective part fails, we're looking for the probability that something fails given it's non-defective. So now we want to look at this non-defective range here, or this bottom one. So our non-defective range, our total non-defective pieces is 461. And we want the ones that fail, and there are 11 there that fail. So as we look at this, when it says we want something that does this, or something that is defective that also passes, do you see how it kind of has this, like, we're shrinking our view? So when we shrink our view, what we need to do is look at it as a conditional probability. Instead of saying, I want to look at everything, how it compares to everything, I'm going to shrink and say, I only want to look at the defective parts. Now within that, what passed, or I only want to look at the parts that passed. Within that, what was defective. We can adjust our verbiage to decide what that is. Now let's take a look at this next example that also has to do with conditional probability. So at school, 60% of kids buy a school lunch. Only 10% of students buy lunch and dessert. So what's the probability that a student who buys lunch also buys dessert? So essentially what this is telling us is we have our table here, and our table has kids that buy lunch and the kids that don't. And it also has kids that buy dessert. This is going to be like they don't buy lunch, and kids that don't buy dessert. So essentially, this is what we're looking at. And what they tell us is 60% of kids here, this is 60%, or not there, 60% of kids buy lunch. Okay, so 60% of kids are somewhere in this category. Let's use blue. They're somewhere in this category. They either buy lunch and dessert, or they don't buy dessert, but they still buy lunch. Now, 10% of the students who buy lunch also buy dessert. So 10% of the overall student body is here, or 10% of that 60% is here. So what's the probability that a student buys lunch, also buys desserts? Well, it's going to be that 10% out of, we're looking at our conditional probability of 60. So that's going to be 1/6. So when we're looking at problems like this, what we want to do is we want to say 60% of students buy lunch. Okay, this right here is our condition. We are only looking at kids that buy lunch now. Of those kids that buy lunch, 10% of students both buy lunch and desserts. So we're looking at 10% is this category here. So if 10% buys both and 60% buys lunch, how many of those people that buy lunch also buy dessert? Well, 10% out of the 60%, or 10% of the student body out of the 60% that buy that, well, that's 1/6 of the people that buy lunch also buy dessert. And that is how that conditional probability takes into account. So again, conditional probability limits our view. So instead of taking the chance that an event occurs over the total, we're now looking at the chance an event occurs over a certain parameter. And that is conditional probability.